This video is intended to show you how to rationalize the denominator, which is a process that we use to remove a radical from the denominator of a fraction. And there are two scenarios that we have to consider. The first is that the denominator is a single radical of some root, of an nth root. And if that's the case, we can simply multiply the numerator and the denominator of the radical by that same nth root to make it a perfect square. So for example, if I have 1 over the square root of 2 and I need to eliminate the radical from the denominator, I can multiply the numerator and the denominator by the square root of 2, because 2 times 2 is 4, which is a perfect square. But if you need to rationalize the cube root of 2, 1 over the cube root of 2, then you have to multiply the numerator and the denominator by the cube root of 4, or the cube root of 2 times 2, because 2 times 4 is 8, and 8 is a perfect cube. You have to make the denominator, or force the denominator, to be a perfect root. So let's take a look at a couple of examples. 1 over the square root of 5. So I have the square root of 5. I need to force the square root of 5 to be a perfect square. In order to do that, I need to multiply it by a second 5. So I'm going to multiply both the numerator and the denominator by the square root of 5, so that I have 1 square root of 5, 1 times square root of 5 is square root of 5, over the square root of 25. But 25 is a perfect square, so we can simplify that, and we end up with the square root of 5 over 5. We successfully have eliminated the radical from the denominator. 1 over the square root of 5 is the same as square root of 5 over 5. In example 2, we have 4 times the cube root of 3. So I have a cube root this time, so I need to make the 3 a perfect cube, which means ultimately I need a set of 3 3s. I can see that I have 1 in the initial problem, so that tells me I need 2 more. So I'm going to multiply the numerator and the denominator by 2 additional 3s, which would actually be the cube root of 9. So I have 4 times the cube root of 9 over the cube root of 3 times 3 times 3. Again, hopefully you realize at that point that in the denominator, because you've forced it to be a perfect cube, you have that full set of 3s, it can be simplified. So we have 4 times the cube root of 9, all divided by 3. Now 4 in the numerator and the 3 in the denominator do not have anything in common, so that's as simple as we can get it. You can also do this even if you have variables in the denominator. Again, you want to force it or create a perfect square in the denominator. So for example number 3, 2x divided by the square root of 6x, I'm going to multiply by the square root of 6x, because I need a second 6 and a second x, multiplied by the square root of 6x. So I have 2x times the square root of 6x over the square root of 6 times 6 and x times x. Again, notice in your denominator now you have a pair of 6's and a pair of x's. And so they can be taken out from the radical. So I have 2x times the square root of 6x in the numerator over 6x. Okay, I'm not quite home free here yet, because 2x over 6x is like a fraction, and we need to try to simplify that. I recognize that 2 can be divided by 2 as well as 6. So 2 divided by 2 is 1. 6 divided by 2 is 3. Also notice that I have an x in common in the numerator and the denominator. So the x in the numerator and the x in the denominator are going to divide out. So I'm left with the square root of 6x all over 3. And again, that would be your answer in simplified form. And you should always simplify your radicals, and you should always simplify your fractions. All right, number 4. We have 10 divided by the cube root of 2x squared. So again, I'm trying to force 2x squared to be a perfect cube this time. So I have 1 2, and I need a set of 3, so that means I need 2 2's. I have x squared, so that means I have 2 x's. To make it a cube, I need 1 more. So I'm going to multiply the numerator and the denominator by 4x, which gives me 10 times the cube root of 4x over the cube root, and I have 2 times 2 times 2, and x times x times x. Again, notice that now in my numerator, in my denominator, I've forced it to be a perfect cube because I have a set of 2's and a set of x's. So I have 10 times the cube root of 4x in the numerator over 2x in the denominator. Again, I'm not quite home free because I do have a common factor. 10 and 2 can both be divided by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. So I end up with 5 times the cube root of 4x all over x. Again, you always want to simplify the radicals and simplify the fractions. The second scenario is that your denominator is a sum or difference that involves a radical, where you have maybe a constant plus or minus a particular number. The idea of a conjugate, in that case, we multiply the numerator and the denominator by the conjugate. It's kind of a fancy math word that means the opposite. So, for example, if you have 2 plus the square root of 3, its conjugate, or its opposite, would be 2 minus the square root of 3. You have the same two numbers, but one of them is a plus, one of them is a minus. If we have -1 minus the square root of 7, then the conjugate would be -1 and 7 with a plus sign between them. So let's take a good look at a couple of examples here. All right. The first example is 3 divided by 5 plus the square root of 7. So this idea of 5 plus square root of 7, it's like they're connected together by that plus sign, or I like to say they're married. Okay, and you can't split them apart or divorce them in math class. So we have to keep them connected. And so I'm going to use the conjugate. So the conjugate would be the same two pieces, 5 and square root of 7. The original one was plus, so now I need a minus to create the opposite, or the conjugate. So I'm going to multiply the numerator and the denominator by 5 minus square root 7. It may help you to put parentheses around these pieces here so you make sure you do the math correctly. Okay, because in the numerator we're going to use the distributive property to multiply the 3 times all the pieces in the parentheses. So we would have 3 times 5, which is 15, and 3 times minus square root 7 would be minus 3 square root 7. In the denominator, we use a technique called full. When you have 2 terms times 2 terms, we do first, outside, inside, last. So we have 5 times 5, which is 25. 5 times minus square root 7 is minus 5 square root 7. Square root 7 times 5 is positive 5 square root 7. And then square root 7 times square root 7 is minus square root 49. And then I'm going to do some simplifying here as much as I can, combining like terms and so forth. So I have 15 minus 3 square root 7 all over 25 minus 5 square root 7 plus 5 square root 7 zeroes out, minus the square root of 49, which happens to be 7. So we have 15 minus 3 square root 7 all over 18. Now here again, you got to be careful because you got to think about simplifying this fraction. I noticed that 15, 3, and 18 can all be divided by 3. So I'm going to go up here and I'm going to factor out a 3. 15 divided by 3 would be 5. 3 divided by 3 would be the understood 1. So I'll get 5 minus the square root of 7 all over 18. And then I can divide out the 3. 3 goes into 3 one time. 3 goes into 18 6 times. So my final answer in its simplified form is 5 minus the square root of 7 all over 6. You got to simplify the radical, but you also have to simplify the fraction. So be extra careful. One more. 6 divided by the square root of 5 plus the square root of 3. You got two radicals, but it's the same process. Again, we're going to use the conjugate. So we're going to multiply the numerator and the denominator by the conjugate. We'd have the same two partners, square root of 5, square root of 3. The original's plus, so we need the minus. So I have square root of 5 minus square root of 3. We're going to multiply that by the numerator and the denominator. Again, parentheses may help you in terms of getting the math right. In the numerator, we distribute. So I have 6 times the square root of 5 minus 6 square root 3. In the denominator, I have square root of 25 minus square root 15 plus square root 15 minus the square root of 9. Then I'm going to go back and combine terms that I can combine. So I have 6 square root of 5 minus 6 square root 3. Square root of 25 is 5. Minus 15 plus square root 15 is 0. Minus square root of 9 is 3. So if I simplify that, I have 6 square root of 5 minus 6 square root of 3, all divided by 2. I then realized that the 6 and the 6 and the 2 can all be divided by 2. So I'm going to factor it out. 6 divided by 2 is 3. So I have 3 square root 5 minus 3 square root 3 all over 2. And then finally, because I have a 2 in the numerator and a 2 in the denominator, they will divide out. And I'm left with 3 square root 5 minus 3 square root 3. Again, you got to make sure you get rid of the radicals in the denominator, but also simplify the fraction in the end. I hope this helps you as you try to learn how to rationalize the denominator.